All right, so let's continue. So let's do quick practice 2.10. So in the figure, BC is a tangent, all right? BC is a tangent, again, highlight the given condition. BC a tangent to the circle at point B, okay? So BC is a tangent, and AC cuts the circle at point D. Write down a pair of similar triangles and prove your assertion, okay? So here, you see that here there are three triangles, okay? The smallest one, and the middle one, and the largest one, okay? The largest one. So which two triangles are similar? So actually here, it is, you can see that angle, it is very, maybe, okay, it is quite obvious that angle DCB is similar to triangle ABC, okay? Why? It is because that the given condition is a tangent, okay? So you see tangent, we have a tangent called angle, and tangent called angle inside the tangent called angle is arc BD. So arc BD is corresponding to angle BAD. So these two angles equal, okay? And then we have a common angle, okay? Angle, triangle, the largest triangle and the smallest triangle have the common angle, okay? So two angles equal, and of course the last angle will be equal, okay? So this angle equals this one. But here, in proving similar triangle, we use two angles, okay? So here we do not need to prove the last angle, the third one are equal, okay? So you can look at your textbook, it is also write two angles equal only, okay? So it means that next time, if you find that two pairs of the angles are equal, and then you can say these two triangles are similar. All right, so now let's write out the step. So question A, okay, solution. Question A, okay, so we can identify that angle BDC is similar to triangle, okay, triangle BDC, okay, corresponding to, so angle B, okay, angle B should be corresponding to point B is corresponding to A, okay, so because this angle equals this one, so of course point B corresponding to point A, okay, and then point D is corresponding to point B, and common angle is C, okay, so corresponding, okay, so we have triangle BDC is similar to triangle ABC, okay? So now let's try to prove it, okay? Let's try to prove it, all right? So because BC is the tangent, okay, is the tangent to the circle, okay? To the circle, this is given, okay? So when you write the proof, draw a line in the middle, okay, and so we can get that angle DBC, okay, angle DBC equals angle B is corresponding to D, okay, DAB, okay, angle, sorry, DAB, sorry, not DAB, angle DBC according to BA, sorry, angle BAC, angle BAC, no, angle BAC, okay, BAC. The reason is angle in alternate segment, okay, angle in alternate segment, all right, angle in alternate segment, and because angle BCD equals angle ABC, common angle, okay, common angle, so we can get that triangle BDC is similar to triangle ABC, okay, is similar to triangle ABC. The reason is AAA, okay, the reason is AAA, okay, it's AAA. All right, so we prove the similar triangle, okay, so our assertion is correct. And then look at question B. Okay, question B. So if AD is 9, AD is 9, and CD is 3. Okay, CD is 3. Find the length of BC. Okay, so find the length of BC. So obviously here we would use the property of similar triangle. Okay, so corresponding the corresponding side similar triangle. Okay, so here we stay again. Okay, because triangle BDC is similar to triangle ABC. Okay, so we want to use BC. Okay, want to use BC in two triangles. Okay, and also use DC. Okay, so given DC, so DC is corresponding to BC. Okay, and then again. Okay, and then BC again. Here we have BC. BC is corresponding to AC. Okay, look at if you write the letter correspondingly, and then it is easy to identify the corresponding signs. Okay, so BC is corresponding to BC is corresponding to BC, the longest sign. Okay, so the reason is corresponding signs, similar triangles. Okay, similar triangles. All right, and then we can get that. So BC square equals DC times AC. Okay, times AC. So it means that here DC given is 3, and AC equals AD plus DC. Okay, so it will be 9 plus 3. Okay, 9 plus 3 equals 36. Okay, so finally BC equals 6 cm. Okay, BC is 6 cm. Okay, BC is 6 cm. Okay, so very simple. All right, so here I give you an extra knowledge. So here in this triangle, you see that BC is a tangent. Okay, BC is a tangent to the circle. BC is a tangent to the circle. Okay, and ADC is a straight line which cuts the circle at 2 point. Okay, 2 point, and you see that this is a short line segment, and this is a long line segment. Okay, so actually AC is called secant. Okay, is called secant. So this is a tangent. Okay, so this is the tangent, the length of tangent. So you see that the length of the square of the length of tangent. So BC square equals the short part. Okay, the short part times the long part. Okay, times the long part. So it means that you have a theorem like that. Suppose this is a tangent. Okay, this is tangent, and this is a secant. Okay, this is a secant, and it is quite easy for you to do some calculation. Okay, suppose this is A and this is B. Okay, the length here is B. All right, and this is C. So you can get that C squared will be A times B. Okay, this is a theorem. So later we will explain this theorem to you also. Okay, so this is some new knowledge for you. All right, so now let's continue. So next part is part C. Okay, part C, a new theorem. So here it tells us that in fact the converse of theorem 2.5 is also true. What does it mean? Okay, what does it mean? So theorem 2.6 tells us that suppose A, B, T are points on the circle. So A, B, T are 3 points on the circle. If TP is a straight line, okay, if TP is straight line, pay attention, here is not a tangent, okay, it's not a tangent. It doesn't tell us TP is a tangent, okay, it doesn't given, okay, it doesn't tell us, okay, or it is not given that TP is a tangent. Okay, so pay attention, it is not a tangent. All right, and it only gives us 3 points and also a straight line, and the straight line satisfies that the angle in alternate segment, okay, this angle, okay, this angle ABT, okay, equals angle ATP. Pay attention. Here we cannot say angle ATP is a angle is a tangent coangle because we don't know TP is a tangent. Okay, so what does this angle? We don't know. Okay, so here it is a common angle. Okay, so actually we don't know what kind of angle it should be. Okay, because we don't know TP is a tangent. All right, so but this straight line TP satisfy a condition that this angle equals angle ABT. Okay, so if it satisfies this condition, then we can prove that by using this theorem, we can know that TP just a tangent. Okay, TP is a tangent. So this is the converse of theorem 2.5. Okay, so here, even though we don't know TP is a tangent, but the given condition, okay, the given condition is that the angle ATP seems like a tangent coangle, okay, and this is an angle in alternate segment, okay, corresponding to angle ATP, okay. So actually we so-called the angle in alternate segment. So we can say, okay, we can say TP is a tangent, okay. So this is the meaning of theorem 2.6, and the short form of the theorem is converse of angle in alternate segment, okay, converse of angle in alternate segment. So now let's try to prove this theorem. All right, so just now the given condition is angle ABT equals angle ATQ. Okay, so TQ has satisfied that it makes the angle ATQ equals angle ABT. All right, so now let's try to prove it. So let's see. So if you want to prove these two angles equal, and you may use, okay, if you want to prove TQ is a tangent, okay, this is given, okay, and prove TQ is a tangent, okay. So you have to record the old knowledge that can help us to prove a straight line is a tangent. So up to now, we only learn one theorem that can help us to prove a straight line is a tangent. It is converse, okay, of tangent perpendicular to radius, okay. Converse of tangent perpendicular. It means that if we can prove, okay, OT is perpendicular to TQ, and then TQ will be the tangent, okay. So we will prove OT perpendicular to TQ, and then we can prove TQ is a tangent, okay, is a tangent, okay. So now how can we prove OT perpendicular to TQ? All right, so first step, we should construct, okay, we should join OT, okay, we should join OT first, okay, join OT, and the same way we extend, okay, OT, okay, extend OT and meet the circle at point D, and then draw. If you want 90 degree, if you want to prove this angle is 90 degree, of course you have to prove the sum of these two angles is 90 degree, and here DT we know is a diameter, so here we can have 90 degree, okay, angle in semicircle, so this is 90 degree, and the same as the proof in 2.5, we know this is alpha, okay, and suppose you see these two angles are, this is beta, and we know this is also beta, okay, because at the beginning we know angle ABT equals angle ATQ, okay, both of them are beta, so alpha plus beta is 90 degree, and of course angle DTQ is 90 degree also, okay, so we can prove that OT perpendicular to TQ, okay, so of course TQ is a tangent to the circle 啦 ，OK。So now let's organize the proof, OK. So the same, OK, it's the same. Join OT and extend, OK. Extend OT and meets the circle at point D, okay, at point D 啦 ，OK, and join also join BD, alright, join BD, alright. So now we know that angle DBA equals angle DTA. The reason is angles in the same segment, okay, angles in the same segment are very easy, and also because angle because DT is a diameter, so angle DBT equals 90 degree angle in semicircle, all right, angle in semicircle. And after that, okay, after that, so we can get that angle, so angle DBA plus angle, okay, plus angle plus angle ABT is 90 degree also, okay, because angle DBA plus angle ABT is angle DBT, okay, it's 90 degree, okay. So, and now we use the condition, okay, use the condition, because angle DBA equals angle DTA, and this is proved, okay. And also the given condition is angle ABT, okay, ABT, angle ABT equals angle ATQ, okay, given. So we can replace angle DBA by angle DTA, and angle ABT is replaced by angle ATQ, okay? So we can get that angle DTA, angle DTA, the sum of these two, okay, angle DTA plus angle ATQ is also 90 degree, okay, is also 90 degree, okay. So it means that DT perpendicular to TQ, okay. So TQ is tangent, is the tangent to the circle, okay, to the circle, okay. The reason is converse of tangent perpendicular to radius. Converse of tangent perpendicular radius. All right. So this is the proof of theorem 2.6. Okay. So up to now you have two ways. Okay, two ways to prove tangent. Okay, to prove tangent. Okay, one is converse of tangent perpendicular to radius, okay? This is the theorem in section 2.1, and here we just learned theorem 2.6. It is converse of angle in alternate segment, okay? This is the theorem 2.6, okay? So you have two ways to prove tangent, okay? Two ways to prove two ways to prove tangent. Okay, so now let's do a practice. Okay, so quick practice 2.1. Okay, quick practice 2.1. So in the figure, PQRS are points on the circle, have 4 points on the circle, and it means that PQRS is a cyclic quadrilateral. Okay, so later if you need the property of cyclic quadrilateral, you can use them. Okay, so AB is a tangent, a very important condition. Okay, if it is a tangent, we will have angle in alternate segment. Okay, so tangent angle. Okay, so later you can use it. And angle BPQ, angle BPQ is 36 degree, and angle PQR is 78. Okay, is 78 degree, and angle CRS is 48 degree, and QS equals QR. Okay, let's look at a given condition. The first one, okay, first given condition, second, okay, and third, some number, okay, and 4, okay, the two sides equal. So when you see two sides, and then we have these two angles equal also. Okay, base angles, isosceles triangle. Later you can use it. So if CR is the tangent, is CR the tangent to the circle, so we want to prove whether CR is a tangent to the circle or not. Okay, so just now I said up to now you have two ways to prove tangent to the circle. So one of it is converse of tangent perpendicular radius. So you see that the figure, it doesn't have a center and a radius. So here we may not construct a center and a radius. So we may choose the second way. Okay, you see here, if you want to prove whether CR is a tangent to the circle, later only if you prove angle SQR is 48 degree also, and then you see these two angles equal for these two angles equal 48 degree, and then you can prove that CR is a tangent to the circle. Okay, so now we try to see whether or prove whether angle SQR is 48 degree or not. Okay, so as we know, the first given condition, let's look at the second condition. So AB is a tangent to the circle. Okay, AB is a tangent to the circle. So this is 36 degree, and let's check the tangential angle. Tangential angle. So look at the arc. Okay, the arc is PQ. So this angle is 36 degree. Okay, angle in alternate segment. Okay, angle in alternate segment. And as we know, PQRS is a cyclic quadrilateral. Okay, it's a cyclic quadrilateral. So we know that angle PSR, mark it, plus angle PQR equals 180 degree. Opposite angles, cyclic quadrilateral. Okay, so we can find this angle okay, angle QSR. Okay, so angle QSR will be 180 degree minus 78 minus 36, and will be 66 degree. Okay, 66. Okay, and use the 4. Okay, use the 4 given condition, and we know this is also 66 degree. Okay, and using angle sum of triangle, we can find that. Okay, we can find that angle SQR is really 48 degree. Okay, so we can prove that CR is the tangent to the circle. Okay, so now let's organize the step. Okay, so solution. All right, so let's see. So because AB is the tangent, okay, is the tangent, AB is the tangent to the circle, So we can have, okay, we can have angle BPQ equals angle PSQ, okay, PSQ, all right, PSQ equals 36 degree. So the reason is angle in alternate segment, angle in alternate segment, okay, and because we use here we can use the first condition because P, Q, R, and S are on the circle. Okay, it means it is a cyclic quadrilateral. So we can get that angle PSR plus angle PQR equals 180 degree. The reason is opposite angles, cyclic quadrilateral. Okay, cyclic quadrilateral. All right. So it means that angle PSQ plus angle QSR plus angle PQR equals 180 degree. Substitute the number. So 36 degree plus angle QSR plus angle plus 75 degree, and then it's 180 degree. So angle QSR is 66 degree, okay, 66 degree. And because let's use the fourth condition, okay, the fourth condition, because QS equals QR, okay, QS equals QR given, okay, so angle QSR equals angle QRS equals 66 degree. The reason is base angles isosceles triangle, okay, and in triangle, all right, and then in triangle SQR, okay, angle SQR plus angle QRS plus angle QSR equals 180 degree. Angle sum of triangle. So we can get the angle SQR equals 48 degree. Okay, and finally, because angle SQR equals angle, the given angle SRC or CRS equals 48 degree. So CR is the tangent to the circle, okay. The reason is converse of angle in alternate segment, okay, alternate segment. So now you may have a break.